All right, number 2 on proving lines parallel practice. It asks us to determine which lines, if any, are parallel, state the postulate or theorem that justifies our answer, and we're using this picture of the 2 lines and the 2 transversals. And number 2, it asks us to figure out which lines are parallel and why. Given that angle CBF, so when you're identifying your angle and you've got all these letters going on, just highlight the angle they're referring to. So CBF is right here, is congruent to GFH. GFH, this angle right here. Well, if you notice, they said that these 2 angles are congruent, and these 2 angles are called corresponding angles. And when corresponding angles are congruent, then the lines that form them are parallel. So, when we're naming a line given all these letters, remember we start off with the symbol for line, and we're having 2 parallel lines, so I'm going to draw 2 of them. And you name a line with any 2 points that fall on the line. Well, here are the 2 lines, and here's the transversal that form those corresponding angles. So the 2 parallel lines are the ones that look like they're parallel, this line and this line. So it would be line KC or KD or DK or however you want to call it, as long as it's any 2 points on that line, and line EG, or you can call it EF or GE. Doesn't matter as long as it's any 2 points on that line. I'm going to call it EG. So line KD is parallel to line EG, and our reason is basically you take the name of the angles, their corresponding angles, and when the corresponding angles are congruent, we call it the corresponding angles converse, because it's the flipped statement of what we learned originally, that when you're given parallel lines, the angles are congruent. Now we're given congruent angles, and we're proving the lines are parallel. Number 4, clean this up a little bit, tells us that angle ACD, so A to C to D is this angle right here, and angle KBF is this angle right here. Well, this one we'd have to look at it sideways, because here's the 2 lines and the transversal, that form these 2 angles. So our 2 parallel lines are the ones that look like they're parallel going up and down. And we can name those 2 lines with any 2 points on the line. But first of all, are these parallel? Well, what kind of angles are these 2 angles? Well, they're alternate exterior angles. They're on alternate sides of the transversal, here and here, and they're on the outermost angle, so alternate exterior. And alternate exterior angles are supposed to be congruent. That way we know the lines that form them are parallel. So because alternate exterior angles are congruent, then the lines that form them are parallel. So I'm going to name those 2 lines with 2 points that lie on the line. I'm going to clean that up a little bit here. So we can do line BF or BH, I'm going to call it BF, is parallel to line AC or AG or JG or CG or any 2 points on this line. I'm going to call it AJ. And the reason those 2 lines are parallel is because our alternate exterior angle converse says that when alternate exterior angles are congruent, then the lines that form them are parallel. Number 6 says find X so that L is parallel to M. So how can we make sure that L is parallel to M? Well, L will be parallel to M if alternate exterior angles are congruent. So the reason that we're going to find X here is the alternate exterior angle converse. And that says that if alternate exterior angles are congruent, then the lines that form them are parallel. So L would be parallel to M. Now, in order to ensure that they're parallel, we have to make sure that they're congruent. So algebraically, we're going to set 3x plus 10 equal to 4x minus 10. First thing I'm going to do is add 10 to both sides of my equation. And I would get 3x equals 3x plus 20, equals 4x, and then that goes away. I'm going to subtract 3x from both sides of my equation. So I'm going to be left with 20 equals x. And I know that's all it asked us for was to find x and give the reason why, but I'm going to go ahead and plug my 20 back in to make sure that these are in fact congruent so that I know that I did it right. So 4 times 20 is 80, minus 10 is 70, and 3 times 20 is 60, plus 10 is 70. So sweet, I did it right. All right, number 12, which of the following A, B, C, or D will make J parallel to K? Well, we're looking for, in our multiple choice, one of our parallel line relationships. If we can find one of our true parallel line relationships, then we can prove J is parallel to K. So, angle 4 congruent to 6. Well, angle 4 and angle 6, if they're congruent, that doesn't prove that those lines are parallel, because 4 and 6 are consecutive interior, and consecutive interior angles are supposed to equal 180 degrees, not supposed to be congruent. Letter B says angle 2 is congruent to angle 7. Well, those are corresponding. They're in the same location on different lines, bottom left, and they are congruent. Well, the corresponding angle converse says that if corresponding angles are congruent, then the lines that form them, J and K, would be parallel. So B would be our correct answer. I'm just going to look over at C where it says angle 1 is congruent to 4. Angle 1 being congruent to 4 has nothing to do with parallel lines. That has to do with vertical angles, and vertical angles have nothing to do with parallel lines, so it wouldn't be C. And then we say 5 and 6 are supplementary. Well, 5 and 6 are a linear pair, and a linear pair has nothing to do with parallel lines. Parallel lines are your alternate interior, alternate exterior, corresponding, and consecutive. So linear pair has nothing to do with it, and neither do vertical angles. Okay, number 14. Which of the following justifies why L is parallel to M? Well, I look at L, S, and M, and I notice that L gives me an angle here that's 80, and M gives me an angle here that's 100. And if you look at these as though S, line S, wasn't even there, we would have 80 here, 100 here. We would have consecutive interior angles. And when consecutive interior angles are supplementary, then the lines that form them are parallel. So the consecutive interior angles converse says that if the consecutive interior angles are supplementary, then the lines that form them are parallel. All right, finding the distance. You have to know the distance formula. That says x minus x squared plus y minus y squared will give us the distance. So I'm going to take my x values. Those are my first value in each set of coordinates. I'm going to subtract them. So -3 minus 2, and I'm going to square it, plus my y values subtracted. So -8 minus my y value -1 squared. -3 minus 2 is a -5. I'm going to square it. -8 minus a -1 is like saying -8 plus 1. So that's -7. I'm going to square it. -5 squared is a positive 25. -7 squared is a positive 49. Together, 25 and 49 is 74. And the square root of 74, if you put that in your calculator, is approximately 8.6. That's the distance between A and B. All right, I'm going to come down here to find the midpoint. In order to find the midpoint, we need to know the midpoint formula. And that says you take your x values, you add them together, divide by 2. And then you take your y values, you add them together, divide by 2. So x is 5 plus x, which is plus a -11, divided by 2. That gives me -6 divided by 2. That gives me -3. So that's my x midpoint. My y midpoint, I would take my y value, -7, add it to my other y value, 6, divide by 2. -7 plus 6 is -1, divided by 2. I can either leave that as -1/2, or I can rewrite it as -0.5. So my final answer, don't just leave it like this, my final answer is a midpoint. It's a coordinate point on the coordinate plane. So I have to address it as a x value, -3, and its y value, -1/2.